Hello everybody, today we're going to be taking a look at harder problems in the topic of Pick's theorem. If you haven't already watched my previous video about the basic concepts and the formulas, please check that out now and proceed with the video if you have a coherent understanding of the formulas and the methods to solve these problems. So without further ado, let's get started. So our first problem is, a polygon of area 12 is drawn with its vertices on the points of a lattice. There are 6 lattice points on the boundary of the polygon. How many points are in the polygon's interior? So for this, it's a rectangular lattice, graph as they have given it. So we can write down the formula here. So the area equals to the number of boundary points over 2. Write that as a capital B, plus I minus 1. And I represents the number of interior points. So we have the formula. Now we know that the area is 12, 6 lattice points, which means that 6 lattice points on the boundary, which means 6 is equal to what B is, and we're looking for the how many points are in the polygon's interior, which is I. So all I have to do is plug it into the equation. So let's write our equation as A equals to B over 2 plus I minus 1. We know that it has an area of 12, so we can plug that in as A. Okay, so we know the amount of boundary points because in the problem it states that there are 6 lattice points on the boundary of the polygon. So you can say that B equals to 6. Now simplifying, we get 3 minus 1 equals to 2. So then 12 equals to 2 plus I. And the number of interior points we can easily find as 10. So that's the number of interior points. And then that's what they're asking. So how many points are in the polygon's interior? So you can say that. So you can see this as your answer. So let's go to the next problem. Okay, so a polygon of area 20 is drawn with its vertices on the points of a lattice. There are 4 lattice points in the polygon's interior. How many lattice points are on the boundary of the polygon? So you can write down the formula again. Okay, so we know the area again is 20. Let me just write the formula. Okay, so we know the area is 20. So A is 20 and we can plug that in. So we have this part of information done. So we need to know that there are 4 lattice points in the polygon's interior, which means that I equals to 4, and they're asking for a boundary, so that means the question is asking for what is B. So we know that I equals to 4 as said in the question. And simplifying, we get, and then we can easily find that the number of interior points is 19. So let's move on to the next problem. If polygon of area 6 square units is drawn with its vertices on the points of a lattice, there are m lattice points on the boundary of the polygon and n points on the interior. M and n are both positive integers. How many possible values of n are there? Okay, so first we need to, we know the formula as a equals to b over 2 plus I minus 1. And then we know that the polygon has the area of 6 square units. So we can write that as 6 equals to b over 2 plus I minus 1. And we know that we can multiply. Sorry about that. We can multiply this equation by 2 to get 12 equals to b plus 2I minus 1, and then we can write this minus 2, sorry, and we can write this as b plus 2I equals to 14. So we have this, and then we need to find the cases which would work for how many possible values of n. So we have that so let me just write down the cases. So we just need to write down the cases when this equation will be true. So we can, when I equals to 0, then b will be equal to 14. When I equals to 1, b equals to 12. I recommend you to try these on your own, but when I equals to 2, b equals to 10. When I equals to 3, b equals to 8. When I equals to 4, b equals to 6. When I equals to 5, b equals to 4. And then these are all the cases that we will have. And we have one last case that I almost forgot, which is when I equals to 6, b equals to 2. So we have these cases, so let's review all these. Okay, so when I equals to 0, any polygon can have a 0 interior, 1 interior, 2 interior, 3 interior. Any polygon can have 0, 1, 2, 3, 4, 5, or 6 to the boundary. We can have 14-sided, 12-sided, 10-sided, decagon, octagon, hexagon, quadrilateral, but we can't have a possible polygon with 2 boundary points, because let's see if we have like this point, and then we have like this point. It doesn't really form a shape because it's only 2 points, and that makes a line. So we have to rule this case out. So then we're left with 1, 2, 3, 4, 5, 6 cases. So our answer is 6 values. So we considered M as the boundary and N as the interior, as it was more confusing, as if M and N were like you had to list as boundary and interior, but this would be more easy as just considering them as boundary and interior without the actual variable. But at the end, you had to remember that the interior is actually N. So you have to find that it is 6 values. So thank you for watching. Subscribe and stay tuned for more videos. And thank you for watching.